Okay, can you stop following me? No, just go away. Go. Are you gonna follow me home? Is that what you're doing right now? See, you can't come in. Oh shit, dude. Oh my god. It's time to turn around. Time to Bruh.
Bruh, no way, bruh. Are you teaching me how to do BB8? Yes, I'm gonna teach you how to model, how to texture, and most importantly, how to procedurally rig. And I know it works very well because I don't animate much, and I've gotten it to the point where a single slider does so much of the character head movement and the wobble and stuff like this. And if you want the project file for what we're about to make, please head over to cgmatter.com, wet your whistle, original project file, and every file from this intro sequence you just saw. But without further ado, let's get into it.
This video is sponsored by Squarespace, and we're going to talk about that later.
First order of business, we need reference, and we don't need to be too sacred about this. Anything that shows what it looks like is good enough for me. And then as for texturing, these are the two images that I need. I literally just looked it up on the internet for like a texture map. This is just for the head basically. And this one is for the panels of the ball, of which there are 6, and they look different, but you can't tell if it's rolling fast. Anyways, modeling the BB8, it's brain dead simple. I love it. Main body is a sphere. I'm going to make sure it's a super high-res sphere. Something like 200 by 100 should be sufficient. Shade smooth, and we're done with that. Onto the head, we are also going to again make a sphere. This one I'm going to bring a bit higher, and I only want to keep the top hemisphere of it. Select everything about here, delete faces, and then really the only thing we need to modify is there needs to be a bit of like a tapering over here so that it fits nicely onto the sphere. So maybe something like that, scale it down, bring it down, Control B right here, maybe a bit of segmentation. that is the head. To get this nice and solidified, I'm just going to select this loop, hit F to fill, extrude upwards just so this is a solid mesh so it interacts with lighting much better, and add some bevels. And by the way we're going to animate this, other than some of the math involved, is the sphere body is we're just going to rotate it about its center, and the head we are going to rotate about the origin of the sphere itself. What that means is that it's going to navigate around the surface of the body. So this is going to be our head material, and for now all we need to do is bring in our texture of the head and then do some fancy project from view or whatever. Here is our nice head texture, and you can see that the mapping originally isn't correct, right? However, the UV unwrap we get by default is a spherical mapping. What that means is if I just kind of stretch this vertically to occupy the image, it's not going to be perfect from the get-go, but you can tell it is mapping correctly. All we need to do is kind of scale this on the x-axis and move it like up and down until it roughly looks correct. And then the only issue is once we have our UV map, set the way we want, is we're going to have some of the UV map over here and over here. This is an issue because it is outside the bounds of the image, and what happens is when you have UV map outside of the original image bounds is there's going to be repetition. Kind of the issue is we're going to get another eyeball over here, or at least part of one, and indeed if I look at the back of the head, it's a vagine. we don't like that. So easiest fix in the world, we're just going to take the section we don't like and essentially, let's get rid of this, and essentially shift it over to sample an area that we do like. Enable this button over here. What this lets us do is we can select part of our UV map and it will select the corresponding part of the mesh. So let's select this section, a bit of this section over here, just slide this bad boy over until we don't get any more problems. Now we have issues over here essentially, so I'm just going to select that section, shift it, just do whatever you need to do to make it look more seamless. Again, you don't need to be too precious about it, and then we sample an area that's white, which seems a bit hard to do because this island is so big. So here's a tip. You can scale it down and it will sample less and less of the image, and then you can just find a nice white area. I guess this eye looks a bit distorted, a bit stretched vertically, and we can solve that by selecting this edge loop over here, which corresponds to some part of our UV map. And if I enable proportional editing, when I edit this, it can shift everything, and I'm just going to shift this by a little on the y-axis. So you can see I can do a kind of local compression over here, and then do an additional pass of modeling that's motivated by this. And that's just something really simple, right? So I'm going to take an edge loop, don't hit G, but hit G twice to do this edge slide. I'm going to edge slide it so that it's perfectly in the right position. Alt E to extrude. along normals, which will let us do this kind of thing, and just bring that in a little. Loop cuts, I guess you bevel those a little. We're just going to add details wherever it's like easy to do so. So for example, here, double G to do a loop cut slide. Select some of these faces, Alt E to extrude along normals, bring that in, and to add a bit of bevel. If you want to get fancy, by the way, you can also do it for these vertical panels. What I mean by that is you can slide horizontally again with that double G, Alt E, extrude along normals, and bring that panel in or even outwards a little. This is really the kind of thing I only expect to see if we're like zoomed in like a lot. So we're going to be adding grunge and other things to make the material look more like physically accurate, but I don't think spending an extra 15 seconds with the modeling is going to hurt anybody. And essentially that is the shading of the head. You know, we're going to do more things to it. We're going to run it through a principled BSDF so that it responds to lighting conditions and all of this. But I think at this point, let's move on to the sphere. Now, I want you to remember that the BB8 has a panel here that is actually duplicated, or it has different panels on 6 sides of it. So we have one on the front, we're going to have one on the left, one on the right, up, down, the thing itself, and then one on the back. You could almost think of this as the sphere is contained inside a cube, and each one gets a panel of its own, and we project it to the sphere instead of needing to model or texture each panel independently. Bring in an image texture just like before, but this time it is going to be the panel. You're going to set flat to box projection, and here is the key insight. You're going to take the texture coordinates of this, which by default is again trying to use UV coordinates, and instead we're going to use generated coordinates, which you can see add 6 panels that are on all the correct sides, but they're self-intersecting. Easy enough. Add a mapping node. I'm going to set the texture to be clip. In other words, it's not going to do any repetition, and now we just need to center it and scale it individually. So you're going to see that when we scale it like this, we're going to get a bit of offset. We can correct for that by just kind of modifying our translation coordinates to fix that. And that's fine, but we're doing a lot of guesswork, right? As I change the scale, we have to like do this, whatever. What I'm going to do is I'm going to add a vector math, which if it's addition will let us offset on the X, the Y, the Z. I'm going to offset by 0.5, 0.5, but then I'm going to weirdly enough undo it. So I'm adding 0.5 and then subtracting 0.5. The reason I'm doing this is we can then inject a scaling inside of here that should be locally fixed at the origin in some sense. So let's try it. I'm going to add a vector math. This one, it's going to be set to scale. In other words, scale it. And it's almost doing the right thing, but I think I got these inverted. We subtract and then we add. And look at that. Now we have a nice kind of procedural scaling that we can mess with. The way you want to think about this is generated coordinates look like this. When we subtract, we get these nice kind of fixed points at every single side of the cube that we'd be projecting on. We then scale, bring it back, and the magic happens. So I'm going to mix color. I'm going to use this alpha pass to say I want one thing within the panels and then a different thing within the black area. So alpha goes here. We look at the mix node, or the white areas of the alpha can receive the texture itself, and then we can change the underlying color. Take the E for eyedropper and select the same shade of like whitish gray. But it's kind of boring, right? There's no like screws or like joining lines or anything, and it turns out that is quite simple to add. I'm going to add a Voronoi texture, which by default is going to use these generated coordinates. You might think, what is the point of this? It adds like these random cells across the mesh. If you take this and reduce the randomness to 0, it's going to make this kind of grid looking pattern. The beauty of this is as I kind of decrease the scale to something like 1, we get these very nice panels that divide this into 8 quadrants or 8 octodrants. I don't know. But if we change what we're looking at from F1 to distance from edge, now we get this nice map that has these lines that I was talking about. I can take this and do a bit of a clamping, and now we get these nice lines right here. Now, instead of just having some like color for the base underneath the panels, we can get a bit more complicated. I'm going to mix with this factor, which will let me pick 2 individual colors. I'm going to change this top color over here to kind of a darker gray to kind of motivate that there's something connecting this and holding it together. I then make this the background over here, and now we have these lines connecting the panels. You could even sample the same gray over here so everything looks cohesive. Now, can we take Voronoi texture further? We can. So I'm just going to duplicate Voronoi texture. This one's going to be back to F1. Now, each one of these quadrants is going to have a origin or kind of like center point that creates them. We can view the distance and then again bring in one of these greater than nodes, but this time it will create these kind of circles. In fact, if I take the scale and bring it up to 2 or even like, I don't know, 4 or something like that, we can get these patterns of dots dots that look quite nice. So now instead of just having this mask represent where we have these gray bindings, I can combine the influence from both of these. How do I do that? I just multiply their contributions. Now we get this combination mask that creates these screws that looks good, in total. And I think this is good enough to, say that we modeled and textured this thing. As you heard me say earlier, the project files are available on my website, cgmatter.com, a website made and hosted with Squarespace, which is the sponsor of this video. So Squarespace is the service I use for website making. It's just like an all-in-one hub that happens to hit every single point that I need. If I want to do code injection because I'm trying to get super custom with my website, I can do that. If I want to host files, whether that be photos, videos, whatever, which I'm doing all the time, I can do that. And most importantly for this website, if I want to do some kind of subscription or payment model, which is what I'm doing, it's kind of like a Patreon alternative, then Squarespace handles that for me. They handle payments and accept everything under the sun. Of course, there's extra stuff that's being added all the time, notably a lot of AI integration and stuff like this. But you can head over to Squarespace, make a website, check out if you like it, and when you're ready to take that website and launch it, go live, use my link in the description to save 10% off your first purchase of a website or domain. Let's just run this again through a principled VSDF, so now it has shading. And I've been getting in the habit recently of taking my model and actually making it to scale, which I haven't done really ever, but it makes setting up the camera and all these things easier. I'm going to imagine that this BB8 is maybe like 2 feet wide. So for the sphere, we can see these dimensions are 2 meters. Did you know you can literally just take this and type in 2 feet, FT, and it will scale it accordingly. I can then scale the head to match this. Looks good enough. Again, we're going to rotate one like this. The other one is going to go around the body, but in a way that, looks like it's looking around. And now let's add in some free details. So for this like albedo pass, we can also get a bump map for free. Bump node, set this to be the height of the bump. So now we have this kind of like normal mapping that we can control. Connect that to the normal, view it. And now you can see we have a bit of extra lighting going on over here that looks super crappy. Of course, the main thing to do is to just play with the strength of this bump. So we can either bring down the strength like this or play with the distance. It looks subtle, but it is better than without it. It does make it look like we modeled some things. And then let's also add a pass of grunge. The way to do that is you just add a noise texture, scale that bad boy up, disable normalize, add a bunch of detail so that we have this grunge pass that I can then multiply over this like original color and all of this. We're going to mix in this dirt pass over here. Let's make this the factor. So now you can see we have this like layer of grime. I'm going to multiply. In other words, this means darken. And now we can say, do we want our grime to be really dark or kind of light? Of course, we want it to be kind of subtle. And just like that, we have a free layer of grime. We don't need to think about it. It just kind of looks good. And if you want, you could just kind of enable normalize and do a bit of a color ramp to get more custom control. And then the final thing we need to do is, of course, this BB8 is metallic. So I'm just going to increase the metal. Maybe let's just add, it's not physically accurate, but like 40% metallic or something like that. And it should be pretty rough. I don't think it's going to be that shiny. Let's take what we just did here with the grime and Control G to make it a node group. Reason for this is I just want to copy what we did over to the head. Just like before, I'm going to add some free normal mapping and then finally add 40% metallic. And now we have this cohesive look for the BB8. Now, I know what you're thinking. Technically, we are missing something, and that is the eyeball. And that is true. But again, it's spheres all the way down. Enable your 3D cursor tool. I'm going to select this eyeball right here. This is going to let me add in a UV sphere centered at the correct point, and I'm also going to align it to the 3D cursor. As we bring down the radius now, it's going to be positioned exactly where it should be with the correct alignment on this eyeball. Add a 3D cursor here for kind of this like second piece of glass. UV sphere, scale it down, and there we go. Let's just add like a simple glass material. And a glass material is nothing more than just a fully white, fully transmissive. I hate EV so much. I don't know why it takes forever to just add transmission. In fact, let's just switch over to cycles while we still can get out alive. A fully transmissive, kind of like low roughness, so like kind of peak shiny kind of glass thing. Right now it's kind of like a big water droplet and it's going to look weird. I want to take this glass element and have it, have some thickness so that it's not going through a giant orb of glass, but kind of like a thin layer. Add a solidify node, which is exactly what lets you give it thickness, if you can kind of imagine that. And then this is without, this is with, this is what's going to make it look correct. Do the same thing over here, just a mild solidification. I guess let's like add a light source just so it has a bit of a red eye. Just select the center of the eye. We're going to make a new material that's only assigned to this. So you can see if I make a new material, it's isolated to this kind of use case. Take the emission, which means glow, make it glow, make that glow red, and maybe make that glow way stronger so that you can actually see it. That looks uggo AF, as the Gen Z say. Okay, so here's a trick of the trade. Select the relevant area that should be glowing and subdivide it a few times. Might seem weird, but listen up. We're then going to limited dissolve, which is going to make it a single face, but a single face with all of these vertices. You then run this command called toSphere, which when we increase it, creates a circle. So now we have kind of like a nice dot that I think everybody's happy with, right? We like that. Okay, this is what I call good enough. And now let's get to the interesting part, which is rigging this mother fricker. Here's how we're going to do that. Make sure that everything in the head is a single mesh. I don't want to have all of these dependencies, right? So select the head, Control J, and now this is a single object. So this is going to be called body. This is going to be called mind, and that's going to be called head. All of these body parts, I'm going to put in a collection and hide them. The reason for this is everything we're going to do is actually just going to be geonodes based. Add in a cube. For this cube, I'm going to import in both of these elements. The first one is going to be object info. It is going to be the body. So now you can see we have the body. And the second one is going to be the head. Now, one thing that is important here is you're going to see that if I transform this geometry, right, like this, you're going to see that the grunge on it kind of shifts. And this is because it's kind of using this coordinate space that is getting moved when the geometry moves. We don't want that. So the trick is click as instance, and now it doesn't happen. And let's start by having this ball go along a path. And specifically, I don't want it to just go along a path. I want it to roll and change direction and roll the correct amount along this path, which would be really hard to do with just a follow curve modifier or constraint or whatever. Let's make sure we have a path. So let's do a Bezier curve. This is going to be our path to follow. Make sure that this is nice and high resolution. And then for our geonodes, let's bring in our path. Now, to get this ball to go along this path, the key insight is the sample curve node. What is the sample curve node? It lets us sample, it lets us get information about a curve at any single point. So for example, here I'm sampling the curve at a factor of 0. What this means is that the curve has its local coordinate system where you can think of this, the beginning of the curve, to have a factor of 0. You progress, you progress, you progress, and it has an endpoint of 1. And for that point, we can extract all this information. What position is it at? What is the tangent at that point? And that information can then be applied to this ball. So I'm going to transform this ball such that it inherits the position at the current factor. So this is already how we do this. And then the second piece of information I need to know is for this ball, what orientation should it have? Which way should it be facing? Well, of course, it should always be facing forwards along the curve. It should always be kind of directing or rolling in a way that says, I'm going to keep going along this curve. That is given by this tangent vector. If we try to plug this in directly to the rotation, it's going to be weird. It's almost correct, but not quite. And this is because the tangent vector, the one that goes along the curve, is just that. It's a vector. It's not a rotation. We can take this tangent vector, do a align Euler to vector. In other words, I have a vector. I want to know what rotation matches it. Connect this here as the vector. And now you can see, especially if I highlight this Bezier curve, you can see it not only follows the curve, but it faces the correct orientation. Now, again, the reason that I'm doing it like this, other than, of course, it's nice and procedural and whatever, is now I can have it roll along this axis, but in a way that is like physically correct. So by the way, what rolling might look like is we take this geometry and rotate it, I guess, along the y-axis before we even do this like tangent transformation. I can have this rotate as a function of time. So this y-axis should be connected to like the time and seconds. So now this rotates, and at the same time, we can animate along this. If these don't sync up, like the rate of the rolling and how fast it's going along the curve, it's going to look super weird. So kind of the cool thing is we can calculate exactly how fast it should be rolling, right? So if I multiply this rotation, say multiply by 3, so it rotates 3 times faster, this still looks wrong. It's definitely closer. We can find the exact correct number for this. Well, first of all, I like this sample curve, but I don't like that it just goes from 0 to 1 along the factor. If my curve is much bigger, then now the factor has to go much faster across space, right? It doesn't care about the size or the length of this curve. So we change this to length. What this means is now I can say, how far have you traveled? Like a meter, 2 meters, 3 meters, 4 meters? It's kind of independent of the scaling of this Bezier curve, right? It just acts in a way that's more physically accurate because we care about distances. So if I have a ball over here and then a surface that it should be rolling on, at every single point in the rotation, it should be contacting the surface, right? At no point is the ball up here. At no point is it intersecting. If the ball is always connected to the surface, what that means is the amount that it traveled along the surface is exactly proportional to the circumference of the sphere. If the sphere has a circumference, let's say 1 meter, for example, a full rotation, once this has spun a single time, it should have also traveled a meter in this direction, right? Because it's always touching. A full revolution of a meter will have it translate traverse a meter. If I can figure out the circumference of the circle, I can then kind of figure out what that rotation should be proportionally. Well, how do I know the circumference of the circle? Well, remember, if you have a circle, we have this formula. The circumference is equal to this number pi times the diameter of the circle. That's just an equation. The diameter of the circle is how far across is it. That can be on the x-axis, the y, the z. If I can get this quantity, I can multiply it by pi and get the circumference of the circle, of the sphere, or whatever. Well, what is the diameter of this sphere? For the body, I'm going to add a bounding box. The key insight is that this sphere and its corresponding bounding box have the same kind of like vertical z component height. So if I figure out how tall is this box, it's also the diameter of the sphere. Well, how do I figure out how tall the box is? Well, we literally have a maximum and a minimum value saying what is the top right corner and the bottom left corner of this box. I subtract these two from each other. In other words, I have the vector that goes from corner to corner, and I only care about how tall is this vector, its z component. This z, this number right here, is the diameter. If I multiply this by the number, you could literally just type in pi, we've extracted that quantity for free. So now we have this whole like animation node group that goes along here. The rotation matches up, and we can rotate along the y-axis. But to figure out, how much to do that, how much roll it should have, we now have this nice circumference number. Remember, how much it rotates is how much we traverse. I don't know why I keep saying that. It's this length saying how far have we gone along the curve. That is going to be a number. So let's say that number is 1 meter. We can then look at the ratio of how much of the circumference is that. So we take this distance we traveled, we divide it. We divide it by this circumference. When we take this now and connect it to the roll of the y-axis, you're going to see it rolls, right? And it is length dependent, but clearly there's something wrong here, right? Well, we're almost there. We've taken the circumference. We've done the ratio of how far we've traversed to the circumference, and that is the amount of rotation. But remember, rotation can be in degrees, like 180 degrees. It can be in radians or whatever. A full rotation, I've done a full cycle, is 360 degrees. We've done a full rotation. We've done 2 pi radians. This y value shouldn't be the number of rotations, but the angle, which is just a multiple of the number of rotations. So you take this, you multiply it by 2 times pi, and now, wait for the magic. Wait for the magic. Look at that. That is a physically accurate rolling. And the reason that it looks correct is because it is correct. Like any other number is going to experience this drift, but this exact number is perfect. Now notice, it's fully dynamic. If I scale it up, now you can see it rolls much slower because its circumference is much, much bigger. If I take this even further and increase the body like this, now you're going to see it roll super slowly. It's kind of like this big boulder. So now a single number tells us how much we roll, but we can do much better than that. We can also have the head follow along. We can animate it dynamically. We can have it respond to the direction. We've fully neglected this head object. Well, this head object should be coming along for the ride over here. And it shouldn't just be moving along the curve, it should also be looking in the correct direction. In other words, after we do the rolling, I'm going to set this to relative, I'm then going to add in our head so that it comes along for the ride, but it doesn't actually roll. So it kind of does a full rotation. It looks this way, it looks that way. Amazing. Now, can we add more to this? Absolutely. So I want you to think of all this animation as fully dependent on this number here. This is the progress or distance slider. I also, for example, want the head to look left and right kind of randomly. A way to do that is I take this head before I join it, and I can, rotate it like this. For example, I can also rotate it along the X or the Y axis, which again will let me kind of go up and down the body. I'm going to do a Z rotation. Let's combine X, Y, Z so that I can isolate this Z component, and let's have it rotate by a random number, a noise texture set to 1-dimensional. What this means is as I increase like the seed or the W slider, it's going to go left and right and left and right and left and right. Disable normalize, so it's going to face the right direction. And for example, if I was to animate this over time, you can see it's really spazzing. So like one thing we can do is we can divide this by like 5, so it kind of, goes a bit slower, or we can have the quality of this random rotation be such that the detail, how sporadic is it? Maybe that detail can be lower, maybe the scale of the noise can be lower, and now you have this very calm motion. I don't want this to be dependent on time, I want it to be dependent on this progress. How far along the curve are we? This is going to be connected to the W slider. Now this doesn't only control how much along the curve we've moved, but also it controls this random looking around kind of motion. Divide it by like 3 or something so that it's much calmer, but now we have this kind of situation going on over here. Now to add some sway, we do have this like X and Y coordinate. So for this like X, this wobble left and right, that by the way maps to this correct direction, so now it's perpetually like leaning to our right side. I can have this go along a sine function. So this is also going to be connected to our traversal number. So as we increase, it will go left and right and left and right. Take this and multiply it by like 10%. So it does this, but way softer. So now it's looking around and it's leaning left and right, which might be hard to tell. So let's bring it up to 30%. And again, the thing I want to emphasize, fully procedural. If I take this Bezier curve and change it with a circle, for example, now we have it so that it does this nice motion, but it's traveling along the circle until it completes the circuit. And I mean, look at that, dude. Simple BB8. You motion track that into your shot, make your money, go home. Okay, so hopefully you learned something from this tutorial. Project files at cgmatter.com. Goodbye.